Welcome back to Chapter 9, Section 1. This is, I guess, technically Part 2. I wanted to spend some time just talking about 45, 45, 90, 30, 60, 90 right triangles. This might be familiar to some of you. It might not be familiar. I might have also just done it really quickly in a previous year. I don't know, and I want to make sure that two things. One, we know that they're special, and then two, we actually don't worry too much about the math. We just let it happen. So first, though, it's going to look a little overwhelming, and we're going to get to it later. We're going to come back to it a lot. I want you to copy down the core concept on page 463. So pause now, bottom of page 463, copy down the core concept. When you unpause, I want you to copy down this triangle, that I just ruined, and I did so nicely. It is a 45, 45, 90 right triangle, and the sides across from the 45s, opposite the 45s is actually a better way of saying it, you have the same lengths, right? If they're the same degrees, the angles form the same length of sides, and then the hypotenuse here is x rad 2. So if this is 2, this is 2, this is 2 rad 2, 3, 3, 3 rad 2, 4, 4, 4 rad 2, for instance. And this pattern is actually really important to easily solve for sides, and then sine, cosine, tan, cosecant, secant, cotan of the trig functions of right triangles. So copy this down. And also, if you need to pause as well, copy down the 30, 60, 90 right triangle. Opposite the 30 side is where you have your smallest side, right? The smallest angle, smallest side is opposite. That's going to be your x. Across from the 60, or opposite the 60, that's x rad 3. And then finally, the hypotenuse is twice the length of the smallest side. So if this is 2, this is 2 rad 3, and this is 4. 3, 3 rad 3, 6, 4, 4 rad 3, 8, and so on. Again, another important pattern to easily identify the sides, and then the 6 trig functions of 30, 60, 90 right triangles, okay? I want us to actually spend some time on this, so I'm going to do example 3 on page 464. Example 3, so this is the top of the page. I'm actually going to do it differently than the book, so if you want to, you can go on the books, you can read the book, you can go on the book's website, and you can you can watch the video that the textbook has to go along with example 3, and they walk you through it one way. You might like that way, go for it. I think my way is a little quicker using the knowledge that we have. So they give us a 30-degree angle, a right angle, so we know that this is 60 degrees. They tell us that this x, the side we want to find, the directions they find the value for x in the right triangle, is right here, and the hypotenuse is 8. Okay, it's going to get a little deceiving because we're using the same variable as we used in our example here. But that's fine, because you know what? You're Algebra 2 kids, it's the end of the year, you're smart enough to handle it, right? So I'm going to use another color, though, just to make sure we separate this. In a 30, 60, 90 right triangle, the hypotenuse is 2x. Across from the 30-degree angle is the smallest side, and then this is the x rad 3 side. The x in black is not the same as the x in blue, all right? So if my hypotenuse is 8, then my smallest side is 4, which then means that my medium side, my other leg, my across from 60, is 4 rad 3, okay? So did you see the logic behind that? I used the fact that I know that my hypotenuse is twice the smallest side, and the smallest side's across from 30. So my hypotenuse is 8, that's what they gave me, which means my smallest side is 4. And now that I know my smallest side is 4, I know that the side across from 60 is just 4 rad 3. We put a rad 3 behind whatever the smallest side is. So my answer is going to be 4 rad 3 for example 3. The book does it through proportions, totally legitimate, and if you want to, you can use that. So let's do one more like this. This is not in your book. It is in the teacher book. It's an extra example 3. Okay, so it's going to be very similar. They give us another right triangle. It's 30 degrees. They give us the hypotenuse is 12, and they want us to find this side. Oh, sorry for the glare. Okay, so we know this is 30, which means that this side is 60. And if we know that this is twice the smallest side. So 12 is twice the smallest side. The smallest side is 6. Therefore, the side across from 60 is 6 rad 3. And that's our answer. If the book's requiring you to put it into a decimal, or if the IXL is putting it on decimal, then you can round to the nearest hundredth or whatever they say. If not, we leave it in simplified radical form. Okay. All right, let's try a 45, 45, 90. So the bottom of page 464, let's do number 5 together. They give us a right triangle, and one angle's 45 degrees. Oops. And I'm already getting ahead of myself. They tell us the hypotenuse is 6. Okay, this is the bottom, page 464, number 5. So they give us a right triangle. This is 45 degrees, which means this is 45 degrees. These two are the same. This is our x rad 2 sign. Remember back to this triangle. The legs are the same value. This is the x rad 2. So if this is 6, this is 6 rad 2. But what's different is that in the triangle they gave us, and I realized that I did a horrible job drawing it. In the triangle they gave us, the rad side is a whole number. Okay, so which means we need to simplify some radicals. This, the 6, is the x rad 2 side. So to solve for x, I'm going to have to divide by rad 2 on both sides. That cancels out. I have x alone. Okay, so 6 over rad 2, I can't simplify that any further as the fraction goes. I'm going to have to multiply by rad 2 over rad 2 to rationalize the denominator. So on top I have 6 rad 2. On the bottom I just have 2. And then now I can simplify the 2 and the 6, and my x is going to be 3 rad 2. All right, so it doesn't look as simple as this. Apparently, 3 rad 2, 3 rad 2, 6 is a thing based on the math. Here, I'm actually going to check my work because it's the first time that you might be seeing it. So my leg is x. I have the value of x being 3 rad 2. If this is correct, this side should be 3 rad 2 with another rad 2 on it, correct? Right? This side, the hypotenuse is whatever the leg is with an extra rad 2 right behind it. So let's find out. Let's check our work. 3 rad 2 times rad 2. Will this get me 6? Well, rad 2 times rad 2 is 2. So 3 times 2 is 6. So I did check my work, and this is the value of x. You might want to pause here, copy this down before you try the problems that I assign. Okay?